Welcome and hello. This is a video exercise in HY-8, and this exercise is titled Upsizing Culverts Before Upstream Development. So if your watershed happens to have development that's planned upstream, then some of the culverts may need to be upsized due to expected increased peak flows for the design storm. That's what we're going to be handling in this exercise. What I have on the screen here is my HMS. That's not an accident. Here's Google Earth, and let's actually bring up HY-8. Here is the HY-8 interface. So let's go ahead and get started with the HY-8, but shortly after we get started, we will need to get the peak flow calculations. All right, so I'm going to go, first of all, make sure you're on US customary units. That's the unit system I'm going to be using for this exercise. And then under project, add new culvert crossing. All right, for the crossing name, I'm going to call this existing. This will be the existing conditions. And we need some data for the flow rate. So let's go ahead and grab that. In fact, now would be a good time to introduce the problem with some information. Here's some of our data. Actually, hold on. Let's go to Google Earth. Okay, here we go. So on Google Earth, I have this one culvert crossing right here at my push pin. It is right here. There's also a couple other crossings, but we're dealing with this one right here. And if I zoom out, here is the watershed. Let me get some watershed properties up onto the screen here. So if I click on measurements, the area is 50.5 square miles. And we can also toggle on and off some of the different colors and displays. So this is less transparent and more transparent. Okay, there's also different colors. That's not too important though. 50.5 is the area of interest. So I'm going to just click OK there. Let's minimize the map. Let's minimize that as well. Let's go over to HMS. I already set up a watershed model. Here is my subbasin. This is the existing conditions subbasin. I realize that this exercise is about high H, but I'm making a quick side quest over here to HMS to get that peak flow. All right, so for subbasin 1, the area is 50.5 square miles. If you're interested in HMS, I do have a playlist for a number of different lessons and exercises in this particular software. All we want to do is get the peak flow, and I'll be the first to admit that the model you're seeing right here is oversimplified just to get some basic numbers. The loss method that I'm going to be using has a 2% impervious, so that's fairly low. And then the transform method, I'm going to use a 6-hour time of concentration and 12-hour storage coefficient. And the meteorologic model is using specified hyetograph. Here is the gauge number 1 data is right here. This is incremental precipitation in inches over that entire 50.5 mile square watershed. And here is the hyetograph. Okay, so let me go ahead and just select my existing conditions simulation. Go ahead and run it. Okay, that's done. Let's take a look at the summary table, and we get 2564 CFS for our peak discharge right here, 2,564. Okay, let's go back to HY-8, or rather the PowerPoint data. That's where I'm getting this 2,564 CFS as our existing discharge. This is our peak flow for the existing conditions that we need to design for. Okay, a few other culvert parameters here. You can see that the roadway is at 40 feet with a minimum freeboard of 3 feet. That means the maximum allowable water surface elevation would be 37 feet. Okay, I need to add the culverts back in here. So there are our culverts. There are 4 8-foot by 4-foot culverts, so 8 feet wide by 4 feet tall. At 20 feet, this represents the invert elevation, so there's no slope in our culverts. It's 20 feet both upstream and downstream. All right, for a total width of 36 feet. So there's not too much room. There's definitely not enough width in 36 feet to add another 8-foot wide culvert barrel. So let's go ahead and build this model right here, the existing conditions in HY-8, run the simulation, and then just confirm that the design flow rate of 2564 does not exceed 37 feet for the headwater elevation. Then we'll come back and check out the proposed conditions, which will involve a higher peak discharge. Oops, spelled that wrong, discharge. And then if so, and it exceeds 37 feet for a headwater, then what would be our culvert for the proposed situation, the proposed scenario? All right, so that's the direction we're going with this HY-8 exercise. Let's go ahead and get started. So what I'm going to do here for the discharge data is go from 0 to 5,000, and then the design flow is 2564 CFS. All right, the tailwater data. Some of the data hasn't been introduced yet, so I'll just be talking about it as I fill out this form. Tailwater, for instance, is going to be a rectangular channel. The bottom width will be 36 feet wide. The channel slope, 0.02 for 2%. And then the Manning's end roughness, it'll be 0.012 for concrete. And then the channel invert elevation will be 20 feet. Okay. If you're interested in looking at the rating curve or the table of data, here's that right there. I'm going to go ahead and close that up now. All right, roadway data. Here we're going to start with 0 to 50 for the stationing, and then 50 goes right there. Crest elevation, that is 40, and then paved, and then the top width, I'm going to set that to 25 feet. All right. Next up, we're ready to add some culvert data. It starts us off with this culvert 1 as the name of a culvert. I'm going to change that to 4 culverts, 4 barrels, dash, 8 feet wide by 4 feet rise, 4 feet tall, add an invert of 20 feet. That's sort of the shorthand way that I've labeled this particular culvert. All right, so 4, let me go ahead and just add 4 down here to barrels before I forget. All right, these are concrete box shaped culvert barrels. So concrete box, the material is concrete, span 8 feet, rise 4 feet. I'm going to say 0 for the embedment depth. And then Manning's N will be 0.012. That's correct. Straight will be the type. And then for inlet configuration, I'm going to select 1-to-1 bevel head wall, which is this one right here, and no inlet depression. All right, last part here is the site data. So I'm going to select culvert invert data, which is what it is already. Inlet station, I'll start that at 0. Outlet station is going to be 40, so the culvert's 40 feet long. And then the inlet and outlet elevation will both be 20 feet. So there's that, a 0 slope. Okay, we're ready to click Analyze Crossing. So let's check out what our data looks like, specifically the headwater at our design flow of 2564. Looks like it's 36.47, which is good because the maximum allowable headwater is 37 feet. If you remember, we go back to this diagram, 37 feet is the maximum because the roadway is at 40 feet and the min freeboard right here is at 3 feet. So that is successful. Now what we're going to do is modify the watershed in HMS and calculate the updated or the proposed peak flows. So let's head over to HMS. I have a separate basin saved as proposed. So if I click on subbasin, the changes that we're making here is the area is still 50.5. We're using the same methods for loss, transform, and base flow. That's a little bit too detailed for a HY-8 exercise though. What you need to know is I'm changing the percent impervious here from 2% to 8%. And then for the transform method, I'm also decreasing the time of concentration from 6 hours to 5 hours, and the storage coefficients decreasing from 12 hours to 10 hours. Okay, so these are all typical and expected changes if there's urbanization and increased percent impervious in a watershed. Okay, so let's go ahead and save and then select our proposed model, click run, wait for that to run. Okay, now we can look at right click and summary table. Another way to access that is this button right here. Now our peak discharge is 2906 CFS. So that's a pretty large increase, about 340 CFS more than it was. So about 10%, a little bit more. Let's close that up and then go back to our HY-8. I'm going to click on edit input data. Actually, I'm just going to click OK. In fact, if we wanted to look at what this front view is, let's go ahead and do that now. So display and then views and then front view and then right click, define roadway profile culvert data. From 0 to 50, we'll say it's centered. So and from 0 to 50, I'll say it's centered at 25. And then the barrel spacing, I'll go ahead and say this is a 1 foot spacing, meaning the side walls of each culvert barrel is 6 inches. Okay. So this is what that looks like for the existing conditions for our design storm. The headwaters up here at just under 37 feet. And then here are our 4 by 8 culverts at an invert of 20 feet sitting side by side. All right, so I'm ready to create a duplicated crossing. I'm going to go right click on the existing crossing, duplicate, and then I'm going to rename this and call it proposed. Proposed, there we go. And then right now, let's edit the data. So instead of the culvert name being what it is here, I'm just going to call it temp because I don't know exactly what it's going to be yet as far as the size or the invert. So let's actually go ahead and just run it right now to see if it satisfies. Here is the results, and here is the design flow right here, 2906. We're up to 40.29, so it actually overtops the road because our road elevation is at 40 feet. So there's a little bit of flow over the road. It certainly has exceeded our allowable 37 foot on the headwater side in elevation. So let's go ahead and go back to edit input data. What if we just changed the rise from 4 feet to 5 feet for all 4 of our culverts? Let's go ahead and see what that looks like. So I'll click on Analyze Crossing. And then for our design flow of 2906, look at that. We got a headwater down to 3446. So that is below 37, and that is an acceptable design. All right, so this may not be the most prudent decision. We may not need to upsize all 4 of our culverts. Remember, if I click OK, we go back to our front view here. Now we have 4 culverts. They're all 8 feet wide by 5 feet high for the span and the rise. But as far as cost and constructability, as long as all 4 of these culverts are working fine, maybe we only need to replace 1 or 2 or 3 of them, not all 4. So what I propose we do for our proposed design is to leave the outer 2 as 8 by 4 and then upsize the middle 2 to 8 by 6. So let's go ahead and do that. We'll update the culverts, the names, the sizes, but we'll keep the invert at 20 feet and then check the flow rates. So I'm going to click on culvert crossing data. The first change I'm going to make is this name right here. Instead of temp, I'm going to call it 2 8 by 4 outer. I'm going to change this back to a 4 for the rise. And then down here for the number of barrels, I'm going to change it to 2. Okay. And then next what I'm going to do is click on duplicate culvert. And what I'm going to name this is similar. It's going to be 2 8 by 6 inner. So these are the 2 new ones, the larger sized culvert barrels. Everything here is the same. The rise needs to change from 4 to 6. And then the number of barrels is 2. So that looks good right there. I'm going to go ahead and click on Analyze Crossing. And then for our design flow of 2906, cool. It looks like our headwater elevation is 3478. That's well below 37. And that will work for our design. Probably a more cost efficient solution than upsizing all 4 of those box culverts. Here is the plan view. I need to update the spacing though. So right click, define roadway culvert. We're going to leave 25 and 25 as the station since they're both centered. But for the outer spacing, barrel spacing, I'm going to change that to 19. I think that will work. So if I click OK, there we go. So now we have the inner 2 that we just added and the outer 2, which are existing. The outer 2 are 4 by 8, or 8 by 4, excuse me, and then the inner 2 are 8 by 6. So if we go back to our PowerPoint here, the answers to our question marks, we'll go ahead and fill that in. Here is our peak discharge for proposed 2906. And then this is the design I came up with in a very short video. Perhaps not the best, but we have 2 culverts that are 8 by 4 and then 2 culverts that are sized 8 by 6, both at an invert of 20 feet. Now, thinking ahead, if I had to make another cost-saving change, I may just try to upsize one of these culverts to 8 by 8, like a true square-shaped box culvert, and then leave the other 3 at 4 by 8, the existing size. But I'm not going to do that. I just wanted to demonstrate in an example how when sizing these culverts, we need to plan ahead and look upstream into the watershed at some of the proposed changes and the potential increase in peak discharge for our design storm, and then make appropriate changes to our culverts to accommodate those peak flows.